Okay. So the directional derivatives is the component of gradient of f. So here f is the scalar point function in the direction of a vector is known as directional derivatives in the direction, okay, that is mathematically we will write dd is equal to gradient of f dot a cap. Now here the a is the just a vector and a cap is the unit vector. That means we can write symbolically we will write del f dot unit vector a. Okay, now this one is the directional derivatives of some vector in the direction of vector a is del f dot a cap. Now we'll see one example. The first one is first question, the question number 1. So question number 1. So find the directional derivatives of x, y, z square in the direction of the vector 2i plus j minus k at the point 2, 3, 1. So in the given problem, what is the or f? F is given. What is the f? F is equal to xy square. Now according to the formula, what is the directional derivatives formula? Directional derivative dd is equal to del f dot a cap. Now in this one, what is the vector a? So a cap, not a. Vector a. Vector a is, oh my god, x, y, z square, and here f a vector. What is the a vector? 2i plus j minus k. So first of all you have to find the del f, that means the gradient of f. What is the gradient of f for this problem? So gradient of f is equal to, that means symbolically del f or I into dou f by dou x plus j into dou f by dou y plus k into dou f by dou z is, what is the result? Anybody? That process ఉన్నామని ఆన్సర్ చెప్తారా? ఆన్సర్ ఏంటో? సిఆర్, హలో, ఆన్లైన్లో ఉన్నారండి? సిఆర్, హారిక, డైరెక్ట్ సాల్వ్ చేస్తారా? ఓకే, ఎఫ్ డో ఎఫ్ బై డో ఎక్స్ వై జెడ్ స్క్వేర్ and x z square and dou z, that means 2x y z into I into j into k. But that point is, what is the point? At the point 2, 2, 3, 1. At the point 2, 3, 1, the del f or gradient of f at the point 2, 3, 1. 3i పక్క కరెక్ట్ అవుతుందా అండి? 3i
plus 2j plus 12k.
Very good. So 2 into 1 square and plus k into 2 into 1 into 3. So 3i plus 2j plus 12k. So it is the gradient of f or normal vector at the point 2, 3, 1. But what is our question? Directional derivatives. So directional derivatives means first of all you have to find the unit vector. What is the unit vector? ikkade raaddamu unit vector. Now we will solve the unit vector. Already we know the a, but we want the a cap. A cap is equal to a. Now 2I plus j minus k. What about the length of this a? Under root of 2 square plus 1 square plus minus 1 square. That means here we will get the 1 by root 6 of 2I plus j minus k. Now what is our actual problem? Directional derivatives. So now the directional derivatives dd. So directional derivative is equal to the gradient of f dot a cap. Already we have the first vector. What is the first vector? 3I plus 2j plus 12k dot 1 by root 6 into 2I plus j minus k. That is equal to 1 by root 6 into 6 plus 12 minus 12. Correct Andy? 2, it's not 12, it's 2, sorry. So 8 minus, it is minus 4 by root 6 is the directional derivatives. Okay. Now I will give the one more question, directional derivative. Just give me the answer very quickly. My God. Okay. Now, so I will give the question. So second question, the directional derivatives of function f. Function f is xyz of, now at the point minus 1 comma 1 comma 3 in the direction of vector is vector I minus 2j plus 2k is option A 7, option B minus 7 by 3, option C 7 by 3, option D none of the above. Which is the correct answer? Answer Andy?
7 by 3, sir.
Sure. What is the gradient of f here?
3I minus 3j minus k.
So gradient of f is equal to I dou f by dou x plus ij into dou f by dou y plus jk into dou f by dou z. Okay. Now after differentiating with respect to x, we will get the yz. After differentiating with respect to y, we will get the xz. After differentiate with respect to the z, we will get the xy. Now substitute x is equal to minus 1 and y is equal to 1 and z is equal to 3. So here we will get the 3 plus I into x, we will get the minus 3 and minus 1. So the vector is 3i minus 3j minus k is the vector. Now what is the directional derivative? So directional derivatives is equal to gradient of f, and what is the vector a? Vector a is equal to I minus 2j plus 2k, but we want the unit vector. So 3I minus 3j minus k unit vector. So unit vector is I minus 2j plus 2k by under root of 1 plus 4 plus 4. That means it is the 3. So 3i minus 3j minus k I minus 2j plus 2k by root 9. That means it is the 3. So the dot product of these two vectors is 3 plus 6 minus 2 by 3. 9 minus 2 by 3, it is the 7 by 3 is our directional derivatives of the given function at the point minus 1 comma 1 comma 3 in the direction of I minus 2j plus 2k. Okay, so one more question I want to give. Can I move? నోట్ చేస్తున్నారా అండి? క్లాస్ నోట్ చేస్తున్నారా?
ఎస్ సార్.
ఎవరండి నోట్ చేసేది? ఎంతమంది నోట్ చేస్తున్నారు? ఓకే, సో నోట్ చేసే వాళ్ళు నోట్ చేయవచ్చు, లేదంటే నోట్ చేయకున్న ప్రాబ్లం, నో ప్రాబ్లం. కాకపోతే రెస్పాన్స్ మాత్రం ఇవ్వండి. సో థర్డ్ క్వశ్చన్ ఈజ్ find the value of directional derivatives of the function f is equal, that means is the scalar point function xy square plus yz square plus zx square at the point 2 comma minus 1 comma 1 in the direction of I plus 2j plus 2k is option A 2, option B 3, option C 1 by 3, option D none of the above. ఆన్సర్ త్వరగా చెప్పాలండి. ఆన్సర్ అండి.
నన్ సార్.
నన్ను ఆన్సర్ నన్నా అండి. వాట్ ఈస్ ద ఆన్సర్? ఎగ్జాక్ట్ ఆన్సర్ వాల్యూ ఎంత ఉంది? వాల్యూ what is the first vector? I vector, a vector I 2j plus 2k and its length is under root of 1 plus 4 plus 4, that means 3. That means a cap here 1 by 3 of 1 I plus 2j plus 2k and the gradient of f, gradient of or del f I into dou by dou x plus j into dou f by dou y plus k into dou f by dou z into this vector x y square plus y z square plus z x square. After differentiating with respect to x, y square plus 2xz plus j into 2xy plus z square. After differentiating with respect to z, here we will get that 2yz plus x square. But the point at the point 2 comma minus 1 comma 1 of 2 comma minus So I into y square 1 and 2xz will get the 4 plus j into 2xy 2xy, so minus 4 plus 1 plus k into 2x 2yz, that means minus 2 plus 4. So here we have the vector 5i minus 3j plus 2k is the this del f at the point 2 minus 1 and plus 1. Now directional derivatives is gradient of f. So gradient of f dot a cap. Already we have the first vector. What is the first vector? 1 by 3 of, sorry, so first gradient of f is 5i minus 3j plus 2k dot 1 by 3 of I plus 2j plus 2k. 1 by 3 of 5 minus 6 plus 4. So 1 by 3 of 9 minus 6, it is the 3 by 3. So the directional derivatives of this function x y square plus y z square plus z x square at the point 2 comma minus 1 comma 1 in the direction of this vector is, we will get the 1. Okay Nandi? Okay. Okay. ఎంతమందికి వచ్చిందని ఆన్సర్? ఎంతమందికి వచ్చింది ఆన్సర్? ఓకే. Okay, one more question. So give me the answer very quickly. This is the fourth one. Find the directional derivatives of function f x square minus 2y square plus 4z square at the point 1 comma 1 comma minus 1 in the direction of 2i plus j minus k. What is the answer? చెప్పాలండి. Here
8 by root 6, sir.
8 by root 6 is the directional derivatives. Answer, very good. What is the del f? మీరు సాల్వ్ చేయండి, నేను ఆన్సర్స్ రాస్తాను. ఓకే. వాట్ ఈస్ ద డెల్ ఎఫ్? డెల్ ఎఫ్ ఏమొచ్చిందండి? డెల్ ఎఫ్ రిజల్ట్ ఆర్ గ్రేడియంట్ ఆఫ్ ఎఫ్? గ్రేడ్ ఎఫ్. వాట్ ఈస్ ద గ్రేడ్ ఎఫ్ హియర్? డైరెక్ట్ రాయొచ్చు 2xi minus 4yj plus 8zk and at the point f, at the point 1 1 minus 1 is, రిజల్ట్ ఏమొచ్చింది హియర్?
2i minus 4j
2i minus 4j plus 8k plus 8k minus 8k plus 8k, sorry minus 8 minus 8, thank you. And one more vector, what is our vector? A cap. A vector is 2i plus j minus k, but we want the a cap. A cap is under root of 4 plus 1 plus 1, it is a 6. And the directional derivatives is the gradient of f del f into a cap. So 2i minus 4j minus 8k into 1 by root 6 2i plus j minus k. That means 1 by root 6 of 4 minus 4 plus 8. 8 by root 6. Very good. But one more question I want to write. Now find the directional derivatives. Directional derivatives. Find direction of. So direction derivatives. Direction of maximum directional derivatives at the point, same point, 1 1 minus 1, and also find its maximum value. Maximum value. Maximum value. Maximum value. Okay, observe in the first problem they have given a vector. What is the vector? In the direction 2i plus j minus k. But here not, vector is not given. So in this situation you have to assume that vector is the gradient of f. Okay, so that I will write in the next line. Okay. So the maximum directional derivatives, maximum directional derivatives is equal to gradient of f dot gradient of f cap. Okay, in the previous lectures it is the a vector, but maximum directional derivatives in the direction of the gradient of f only. Okay, now already what is the gradient of f in the previous calculation? What is the gradient of f? Already gradient of f is ఏమొచ్చిందండి? Gradient of f 2
I minus 4j minus 8k.
okay. Okay, now we will use the same results. So gradient of f, so gradient of f already we have 2i minus 4j minus 8k, and you have to calculate the gradient of, sorry, it is length of the vector. What is its length? 4 plus minus 4 square minus 8 square, or after simplification 4 plus 16 plus 64, that means it is under root of 84. Now simplify. So already we have the gradient of f 2i minus 4j minus 8k and the its cap. So 2i minus 4j minus 8k by under root of 84. So 84. Now the dot product of these two vectors is 4 plus 16 plus 64 by under root of 84. So it is 84 by under root of 84. We will get the under root of 84. Okay, so this is the calculation. Okay, or we can calculate directly also. How? So the maximum directional derivatives is gradient of f. So gradient of f. So gradient of f and grade f cap. So grade f. So this one we know that grade f by now. It is equal, we can write the dot product of these two vectors is grade f whole square by grade f. So mod of the gradient of f. Directly we have the already mod f, gradient of mod f. Directly you can use the result. That means root of 84 is the result. Okay. So finally the conclusion is the maximum directional derivatives no need to calculate like this directly. The maximum directional derivatives just to calculate the length of gradient of f. The length of the gradient of f is the maximum directional derivatives. Okay, Nandi? Now I will give the homework problems to you. Just to try to practice these problems. Okay. Now I will give the homework problem. Homework problem, first one. I will give the only one problem. Find the directional derivatives of f is equal to x square y z plus 4x z square at the point 1 comma minus 2 comma minus 1 in the direction in 2I minus j minus 2k direction. ఆన్సర్ ఇవ్వాలండి వద్దండి ఆన్సర్ ఇవ్వాలా ఆన్సర్ no need. Okay, anyway I will give the answer. It is 37/3. Next one same, it is sub question and find direction of maximum directional derivatives at the point 1 comma minus 2 comma minus 1 and also find its maximum value. So maximum value, okay, just to try to solve these two problems. Okay, one is the direct one is the directional derivatives of f at the points 1 minus 2 minus 1 in the direction of 2I minus j minus 2k, and the second question is find the maximum directional derivatives of this function at the point 1 comma minus 2 comma minus 1. Okay, and also find its maximum value. Okay, now this one is the about the directional derivatives. ఒక్క నిమిషం అండి. Tangent vectors. ఓకే, ఆన్సర్ వచ్చిందా అండి? ఎవరైనా సాల్వ్ చేస్తున్నారా? Nobody? ఎవరైనా సాల్వ్ చేస్తున్నారా? Okay, leave it. Okay, so try to solve these two problems. Next one applications of the directional derivatives. The question is So applications of directional derivatives or vector differentiation. So the question is here, suppose a particle moves on the curve x is equal to 2t square and y is equal to t square minus 4t and z is equal to 3t minus 4, where t is the time, at the t is equal to 1. Now, how can you find the ఇది అయిపోయిందండి లాస్ట్ క్లాస్లో. సిఆర్ హారిక అవ్వలేదు. ఓకే. సో క్వశ్చన్ ఈజ్ దట్ ఫైండ్ component of velocity at t is equal to 1. Velocity now what is the position vector according to the previous problem? Position vector is here xi plus yj plus zk, and it is given that vector in the form of parametric form. That means the position vector is here 2t square I plus t square minus 4t into j plus 3t minus 4 into k. So this is the position vector, but what is our question? Our question is velocity. Velocity is, what is the formula for velocity? Velocity, see here, dr by, so rate of change. So already we have the r is the vector, that is 2t square I plus t square minus 4tj plus 3t minus 4. So differentiate with respect to t. After differentiating with respect to t, you will get here it is the 4t I plus 2t minus 4j plus 3k, but it is clearly given at the point at the time t is equal to 1. So t is equal to 1. Now this velocity, that means v at the point t is equal to 1, that is dr by dt at the point t is equal to 1 is, here we will get the 4i plus 2 minus 4j plus 3k. That means 4i minus 2j plus 3k is the vector. Okay, this is the velocity, but the question is that, so this is the velocity. And one more question I want to add here, find the component of the velocity at t is equal to 1 in the direction of, I minus in the direction I minus 3j plus 2k. Just it is the only velocity at the t is equal to 1. Now we have to find the component of the velocity at t is equal to 1 in the direction I minus 3j plus 2k. Now already we know that it is nothing but it is the directional derivatives, and the vector is already here v is equal to 4i minus 2j plus 3k, and the vector is given that a is equal I minus 3j plus 2k. Okay, now the calculation of the component of the velocity in the direction, the component of velocity in the direction a, I minus 3j plus 2k direction is, just to simplify the dot product of the v vector and this direction a cap. So what is the velocity? What is the calculation of velocity? Velocity వచ్చిందండి 4i minus 2j plus 3k is the vector v, and the a is given I minus 3j plus 2k by its length. What is the length of this vector? Under root of 1 plus 9 plus 4. That means 4, the dot product of these two vectors. What is the dot product of these two vectors? 4 plus 6 by root 14. That means 16 by root 14 is the velocity in the direction I minus 3j plus 2k at t is equal to 1. Similarly, same one more question I want to add in this one. So it is the first question. Second question is, and also find the acceleration, also find the component of acceleration at the point t is equal to 1 in the same direction I minus 3j plus 2k. Now it is the calculation of velocity. Now how can you find the acceleration of this particle? Acceleration చెప్పండి. Acceleration dv by, very good. So acceleration is dv by dt or d square r by dt square, both are same meaning. But already we know that what is our vector v is equal to, or dr by dt is, already we have 4t I plus 2t minus 4j plus 3k. Just again differentiate with respect to t. After differentiating with respect to t, again what will the result? 4i plus 2j 0 into k. This is the our vector. I will write the name. So dv by dt, simply I am writing it is the vector A, acceleration. But what is our question? The component of just I will write the second. Okay, it is the first problem, this is the second problem. The component of the acceleration in the direction a vector I minus 3j plus 2k direction. What is here? Just you have to calculate the a dot a cap. A is the acceleration and a cap is the given vector. What is the a? So a here 4i plus 2j, and a cap. What is the a cap? A cap వచ్చిందా అండి? We don't have. So my I minus 3j plus 2k by under root of 1 plus 9 plus 4. What is the dot product of these two vectors? 4 minus 6 plus 0 by root 14. That means minus 2 by root 14 is the acceleration in the direction I minus 3j plus 2k only. Okay? Am I clear? Okay, Nandi? Okay, now I will give us, madam. Sir, Harika?
Yes, sir.
Doubt? Huh?
No, sir.
Okay. I will give the homework, one homework problem in this directional derivatives. Now a particle moves on the curve x is equal, y is equal, z is equal. Now x is equal t square plus 1 and y is equal 4t minus 3 and z is equal 2t square minus 6t. And the question is where t is the time, where t is the time, find the component of velocity and as well as acceleration at t is equal 1 in the direction I minus 2j plus 2k. Try chestarandi. Here we have the two questions: velocity, a component of the velocity, and acceleration of the velocity in the direction I minus 2j plus 3k. Okay. సిఆర్ మీకు ఈరోజు మీకు మళ్ళీ క్లాస్ ఏమైనా ఉందా, ఫిజిక్స్ క్లాసు ఇప్పుడు
ఉంది సార్.
ఏ టైంలో ఉంది?
11:30 సార్.
11:30. ఎప్పటి వరకు క్లాస్ తీసుకోవచ్చు?
11:15 సార్.
11:15 వరకు కరెక్టేనా? ఓకే, ఆ టైం తీసుకోవచ్చు కదా, ఏ ప్రాబ్లం లేదు కదా?
నో సార్, నో ప్రాబ్లం.
నో ప్రాబ్లం, గుడ్. Next one, so one more topic. So up to now we have seen only gradient of f. So gradient of f is related to here it is related to only scalar point function. Next one I will introduce one more, vector point function. So we have the two types of point function, one is the scalar point function and another one is the vector point function. Next one, now we will introduce the vector point function. So this one is the function but it is vector. So example, suppose f is the vector is x square I plus y square j plus z square x into k. So this is the a vector and it is involving the x variable, y variable and z variable. So this is the function. So this is the vector point function. Now what about the physical meaning of this vector point function? Anybody? Here physical meaning of vector point function. Mathematically it is the function and it is a vector, but what is the physical meaning of vector point function? Here cheptara. Here CR, no CR. Okay, now the definition of the vector point function: if to each point P in the region or in a region, or suppose assume this is the x-axis and y-axis, z-axis, that means it is the I-axis and j-axis, k-axis. So there is a function, there is a region, there is a function, or and there a corresponding, there corresponding a vector v, or I will write symbol is f of p is the vector, and then we say that this is, we say this f of p is a vector point function, vector point function. So example, this is the one of the example, this is the one of the example of vector point function. And now the previously we have the scalar point function and del f. If f is the function, if f is the suppose scalar point function, now del f is nothing but gradient of f. Now same here I am taking the f is the scalar vector point function, vector point function, and it is now the a vector, and del is the vector, and del dot f is, it is gives the vector or scalar. So gradient of f always gives the vector. Now I am taking here the vector point function and del operator. The result must be the dot product of the two vectors, always a scalar only, and this del dot f we will write this is the grade del into f is the grade f, and del dot f we will write the div f, that means divergence. So next one is the, suppose I am taking the f is a vector and del dot f, del dot f I into dou by dou x plus j into dou by dou y plus k into dou by dou z into, that means dot, f is a vector, that means I f1 plus j f2 plus k f3. The dot product of these two vectors is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Now this is the dot product of the two vectors, one is the del, another one is the f, and this mathematically okay we can write the del dot f, and but we will call it is the div f, or also we will call it is the divergence of f. In the previously del into f, it is the gradient of f, and here the div f, div dot f we call it is the divergent of f. Okay, so the next one is the one more topic is divergence of a vector. So divergence of vector f, divergence of f. Suppose here I am taking f is any vector point function. So f is any vector point function, f is any vector point function, and f is I am writing here f1i plus f2j plus f3k, then the divergence of f we'll denote it by like this, is defined by div dot f, and calculation is the dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So this one is the divergent of a vector point function f. And we will see two problems, then we will stop. Divergent of vector. Now the first problem is find the divergence of function f is x square plus yz I plus y square xz j plus z square plus xy k at the point 1, 2, 3. This is very simple. So divergent of f, or same question they will write like this, so div f or del dot f. What is the div f here? So div f is, or del dot f is I into dou f1 by I into dou f by dou x plus j into dou f by dou y plus k into dou f by dou z in dot x square yz I plus y square xz j plus z square plus xy k. Now the dot product of these two vectors, so dou of x square plus y square and by dou x and dou y square xz by dou y plus dou z square plus xy by dou z. So after differentiating with respect to x, we will get the 2x, and after differentiating with respect to 2y, and after differentiating with respect to z, we will get the 2z. Now this one is the divergent of f, and we want to calculate divergent of f at the point 1, 2, 3. At 1, 2, 3, it is the 2 into 1 and 2 into 2 plus 2 into 3. So that is 2 of 1 plus 2 plus 3, that means 6 into, so we will get the 12. So 12 is the divergent of f. So 12 is the divergent of f. ఒక్క నిమిషం అండి. Now I will give the one question, just give me the answer. Second one, the divergent of f so divergent of vector field, here vector is e power x cos y I and e power x sin y j. Option A 0, option B e power cos y, option C 2 into e power x sin y, and option D is 2 into e power x cos y. Which one is the correct? Answer? ఆన్సర్ చెప్పాలండి.
D, sir.
ఆన్సర్ అండి డి. షూర్?
Yes, sir.
Okay. Now we'll check. So question is div dot f, that means dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So this is the f1, this is the f2, and f3 is 0. After substituting, so e power x cos y plus dou f5 by e power x sin y plus 0. So after differentiating with respect to x, we will get the e power x cos, and after differentiating with respect to y, we will get the again e power x cos y. So 2 into e power x cos y is the result. So correct. So option D is the correct. Very good. సిఆర్ ఇంకెంత టైం ఉంది సిఆర్? ఉందా అయిపోయిందా సిఆర్ మనకి?
15 minutes ఉంది సార్.
ఇంకో 15 minutes ఉంది. ఓకే, నౌ విల్ discuss one more question. Gradient of, so divergent of f. Now here sometimes maybe the gradient of f0, sometimes maybe the gradient of f0, for example ఒక్క నిమిషం అండి. ఎక్కడ ఉన్నా తల్లి? Suppose now one more question. Suppose here f is equal to here zi plus xj plus yk. Now the divergence of this vector f is, the divergent of this vector is I into dou by dou x plus j into dou by dou y plus k into dou by dou z into this vector f is I into dou f by, so dou by dou x, j into dou f by dou y plus k into dou f by dou z. Here f is equal to zi plus xj plus yk. Then it is I into dou z by dou x plus j into dou x by dou y plus k into dou, so not k, so it is 1 1 1, dot product of the two vectors, so dou y by dou z, so it is entirely 0 plus 0 plus 0. So here this divergent of this vector is 0. If the divergent of vector 0, we call that is the, what is that vector? What is the corresponding vector? We call that is, Chepali, that f is called as solenoid vector. Very good. So f is called as solenoidal vector. Okay, that is our next topic. So solenoidal vector. Solenoid vector. So what is the statement? If suppose the divergent of f0 or del dot f0 or divergence of vector f 0, then this f is called as vector f is called as, that means this vector point is called as solenoidal vector del vector. Okay, so this is the one of the example. So this is the one of the example. Next one we'll discuss one more. Second one. So this is the last problem. Second one. So f is equal, here I am taking f is the vector x plus 3y and y minus 2z plus x minus 2z into k. Is it a solenoidal vector? Is it? Vector or not? Tondar cheppala answer.
No, sir.
Yes or no?
Yes, sir.
కొందరికి నో, కొందరికి ఎస్. అదేంటి?
Yes, sir.
ఇప్పుడు నోన్ ఎస్ అంటున్నారా? సోలార్ వెక్టర్ అవుతుందా అవ్వదు? What is the divergent of this vector f? 0 or non-zero?
Non-zero.
Non-zero. Okay, now we'll check. We'll try. Now div f or del dot f, both are same meaning. I into dou f by dou x plus j into dou f by dou y plus k into dou f by dou into f. F, what is the f vector here? In general I am writing I into f, f1, f2, f3, k. సో మీరు ఎలా అయినా సాల్వ్ చేయండి, డైరెక్ట్ సాల్వ్ చేసినా ఓకే, లేదా ఫార్ములా రాసినా ఓకే, మీ ఇష్టం. బట్ డైరెక్ట్లీ ఐఎమ్ యూజింగ్ ద ఫార్ములా డైరెక్ట్లీ. ఓకే, సో మై సజెషన్ ఈస్ జస్ట్ డైవర్జెంట్ ఆఫ్ ఎఫ్, just use this formula directly. So this is our f1, this is our f2, and this is our f3. Now substitute dou for differentiation of x plus 3y, differentiation of y minus 2z, and differentiation of x minus 2z. Now first one is 1, second one is 1, and third one is minus 2. It is entirely 0. So the given vector f is, this f is now solenoidal vector. Okay na andi? Okay? Okay na andi?
Okay.
Okay. Now I will modify the same problem. I will modify the same problem like this. Copy. Paste. Okay, now I will modify the problem. So small modification. If suppose this vector is solenoidal vector, then find the here occurs symbol cheppu here. Okay, now I am taking here the lambda. Then what is the lambda value? So the question is here, f is the vector x plus 3y I and lambda y minus 2zj plus x minus 2zk is the solenoidal vector. What is the lambda value? We know the answer. What is the lambda value here? 1. 1. So we know the result, but now we will solve. So already it is clearly given. It is the solenoidal vector. So first of all you have to assume it is equal to 0, 0. So 0. Entirely we have to assume it is the 0 only. 0. And lambda, I think here the lambda, now here we will get the lambda 1. So is equal to 0. So lambda minus 1 is equal to 0. Now the lambda is equal to 1. If the lambda is equal to 1, this is the solenoidal vector. The previous question is the direct. Okay, verified. But here they have given clearly it is the solenoidal vector. You have to find the unknown value. Okay, now anyway I am giving the homework problems to you. Just to try to practice the problems. Okay, the homework problem. ఇంకా టైం ఉందా సిఆర్ మనకి ఏమైనా అయిపోయినట్టుందా? సిఆర్ ఉన్నారా? ఓన్లీ 5 minutes. ఇది సరిపోతుందండి 5 minutes. Suppose we have the vector x plus 3y I plus y minus 2z k plus x plus lambda z into k is solenoidal vector. Then find the unknown. That's the first question. Second question, if the vector f is a solenoidal vector, that is the 3x minus 2y plus z plus 4x plus a y minus z into j plus x minus y plus 2z into k is solenoidal vector. And third one, if f is equal to x, y, x, z. So 6x plus yz, ఒక్క నిమిషం అండి. So not 6x, sorry, it is the 2 only. 2x j, sorry, I plus 4y plus xz into j minus dollar into z minus xy into k is solenoidal vector. Then find the, what is the first question? Find the lambda value. Second question, find the a value. And third question, find the dollar value. Find the dollar value. Okay.